It's tangent time. So, last time we learned about inscribed angles, which is a special segment or special couple of segments inside a circle. Now we're going to learn about the only special segment that lives completely, well, almost, very almost completely outside of a circle, a tangent. So, tangent to a circle is a special kind of segment that only touches the circle in one place. So it only just barely kisses the circle. So line AB is tangent to circle C. And that point, that one single point where it touches, is called the point of tangency. So that's what a tangent to a circle is. First theorem about tangents is, excuse me, in a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So if we have this guy right here, this is tangent to the circle if, and this line down here is tangent to the circle if and only if this segment is a radius and it is perpendicular to this line, right? So only if both of those things are true. Let's do a couple examples. All right, first example, segment JL is a radius of OG. So it's saying that this is a radius, right? Determine whether KL, so this one, is tangent. Oh, there's more words that go in that sentence. How about we say to circle J? Right? So we want to know if it is tangent. So if it was tangent, basically what we're trying to prove is this perpendicular? Is that true, right? Is this a 90-degree angle? So how can we do that? Well, we learned that if we basically use the Pythagorean theorem and a squared plus b squared does in fact equal c squared, then it's a 90-degree angle. So that's what we're going to do. So this is A and this is B. C, though, we need to figure out. So it says that JL is a radius, which means that J is the center. So that means that JL and J whatever, we don't know, is also 8. Right? So we can write the formula a squared, or 15 squared, plus b squared, or 8 squared, equals bless me. Bless me. Bless me. All right, so 9 plus 8 squared. So let's see. Ooh. 15 squared is 225, I think. Let's find out, shall we? I think that's right. 15 squared is 225. Look at me. 225 plus 8 squared is 64 equals 9 plus 8 is 17. All right, so 225 plus 64 is 289. So what does 17 squared equal? 17 squared, enter, 289. 289. So, yes, it is tangent. It is a tangent line because JL is perpendicular to KL. Right? Because that, right? We could write a little proof for this problem if we wanted to, but we don't have to. So let's do the next example. I think it's an example. Yep, I was right. So JH is tangent. So this JH is tangent to circle G, right? So we want to find the value of X. So these are radii of circle G, right? So we can basically use the same formula. So because of the theorem we just said, we know that this is a 90-degree triangle. So we know that x plus 8 squared equals x squared plus 12 squared, right? So we can set up the same sort of formula. So x squared, this one squared, x squared plus 12 squared equals x plus 8 squared. Uh-oh. We're going to end up with a little quadratic happening here. I bet we're going to get a positive answer and a negative answer, and we're going to have to, like, throw one out. Well, let's find out what happened. Okay, so x squared plus 12 squared. 12 squared is 144. We need to split this into 2, right? This common mistake, I talk about it all the time in Algebra 1 and Algebra 2, is what you're tempted to do is x plus 8 equals, or squared, equals x squared plus 8 squared, and circle it, move on. But that is not what's going to happen here. You're missing a whole term if you do that. And so what you have to do is you have to say this is x plus 8 times x plus 8, which is the same as squaring it. Now, there is a shortcut to do this quicker. We're not going to worry about that right now, but you have to FOIL this whole thing out, right? So we have to do this times this, and this times that, and this times this, and this times that, right? Got to do the whole thing. So we've got x squared plus 144 equals x times x is x squared. X times 8 is 8x. And 8 times x is 8x. And 8 times 8 is 64. All right, so let's see what we can do cleanly with our different color in one step. So let's subtract x squared from over here. Combine it with its friend over there. Well, look what's going to happen. They're both going to cancel. That's handy, right? And then we've got some like terms here that we can combine. And we can subtract 64 from both sides. Right? See, when we do it neatly like this, we can get away with these kind of shenanigans, right? But you gotta keep it neat. So 144 minus 64. I don't know, feeling tired. Liable to make a dumb mistake. 80. That's what we thought. 80 equals 8x plus 8x equals 16x. So divided by 16 equals 5. X equals 5. Should write that step in there. By 16 divided by 16. And x equals 5. No big deal. We ended up with just one answer, so we didn't have to worry about throwing out one, or it's this or that, or whatever else. Good to go. Next and last theorem in this video. If two segments from the same exterior point are, so exterior point B in this case, are tangent to a circle, they are congruent. So in this case, since both of these two circles, both of these two line segments, AB and CB, go through the same exterior point, and they're both tangent to the circle, right? Because that's true, this one is congruent to that one, right? Easy peasy. That's going to set up some of our favorite kinds of equations, easy peasy ones. So AB and CB are tangent to circle D. Find the value of x. So since both of these are tangent to the circle, they go to the same point, that means these are congruent, which means we can set them equal and solve for x. Easy money, right? X plus 15 equals 2x minus 5. Going to subtract x from both sides. Let's move this one over here. We'll end up with a positive x that way. Minus x minus x. If we move this one, that means we need to move this other one this way. So plus 5. Plus 5. You can, of course, do these in two steps, or in two lines, I should say. And that would be totally fine. I don't know why I wrote a 2 there. You know, things happen. How about a 5? Okay, so that cancels, leaving us with 20 equals x. Before we circle, are we looking for that? Find the value of x. We are, in fact, looking for that. That's it. That's all there is for this lesson. We will see you in the next one, which will be something. Secants, tangents, and angle measures. Sounds like more theorems to me. We'll see you there. Hope you're having a good day. Bye-bye.